So the other thing that's included in the homework is the applications like this. And you'll know that you'll recognize this one from grade 10 basically. It's really not different from what you've done in grade 10 and 11, but it has a bit of a grade 12 spin to it. We can think about it in a bit of a different way. And then you could absolutely have other applications. Like this one's just a quadratic, so it's pretty straightforward. But you could have other ones that were other kinds of functions that are grade 12 functions, and you would solve it in the same kind of way. Okay? Or it would be much more complicated, but when we have had those graphs in the past where it's like two higher order polynomial functions that cross, and where do they cross between which values? I mean, you could have an inequality word problem. It would be complicated, but with that, right? So I hope you follow me. There are different kinds of grade 12 applications you could have, but we're just going to look at a simple one. So somebody throws a rock off a cliff, and it gives us the equation that the path of the that models the path of the rock. H is height in meters, t is time in seconds. Question A is absolutely literally a grade 10 question. When does the rock hit the ground? So how would I do that? Roman.
Solve it.
Yeah, but so solve it how? Like what do you mean solve it?
Oh, well, factor the different function.
Okay, very good.
I was just going to say since h of t equals the height and it's a ground level, therefore we sub in for 0.
Good. So we sub in for 0 first. So this is like saying h at t equals negative 5t squared plus 8t plus 12 at h equals 0. So Roman, when you said solve it, this isn't really a thing I can solve, right? You got to solve for something. So solve when h equals 0, which is that was in your head, you were implying that. So we set it equal to 0, and then this has actually become something that we can solve. I believe this popped up on the quiz, or maybe a learning goal recently. I think it was a quiz, yeah. Really dangerous to try to solve anything when the leading coefficient is negative. Like, bad idea, okay? So I would, by 100%, now if you're using the quadratic formula in this case, not a big deal, but I would 100% divide everything by negative 1. When it's 0 is the only case you can do this. Please don't make this mistake. That's a grade 10 mistake. If it's equal to 8 or something like that, you can't necessarily do this. Or if it's equal to y, you certainly can't do this. But if you have an equation equal to 0, then I can multiply everything by negative 1, and I still get 0 equals positive 5t squared minus 8t minus 12. So let's do the discriminant and see what this thing is like. So b squared, which is 64, right? That's always going to be positive because it includes the negative sign. And then it's going to be minus 4ac. This is how I do it, like to try to speed it up in your head, right? Most of you have probably thought this through on your own, but negative 4ac. So a is positive, c is negative. It's got two negatives in it. It's going to end up being a plus. So I would just do 64 plus 4 times 5 times 12. And it gives you 304. And hopefully you recognize that's not a perfect square, but check it anyway. Not a perfect square means quadratic formula, not factorable, so we got to use a quadratic formula. Okay, very good. So that means t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So t equals negative 8, which is 8. Negative 8 squared minus 4. So this is where you get to really see, whoops, what I mean by that. So right here, if you want to see this again, I was just looking ahead. That has two negatives in it, so it's going to turn out to be plus, right? So that's why I added. Just speeds it up on your calculator a little bit. And then that equals 8 plus or minus the square root of 304 over 10. So I don't have to reduce this unless the question for some reason said that. This is an application. We're interested in the actual time. So I would break this up into, this is the step where I would break it up into 2. And I get 2 answers. I don't think it told us what to round to or anything, so let's see. Careful of brackets. So this one I got 2.5. And this one I got negative 0.9. 2.54 and negative 0.94. Good luck. Who are you playing?
St. David's.
So what do I make of this answer?
Only the first answer works because they came with a negative time.
Okay, good. This is where we start thinking about what our, like, interpreting our actual answer. It's so funny when people start doing this in grade 10 and you show them this. And so this is what we do. Now you folks, listen carefully to me. This is for marks. You have to get both answers to the end like this. And then you have to, like, somehow, this is how I would do it because this is how we typically do it, but somehow communicate that one of them is no good. You don't have to exactly say why, okay? But I always circle, give it one little thin cross out so you can still kind of see the number behind it, but it's clearly crossed out, and say inadmissible. Because it's a negative value, which makes no sense in this case, right? You have to do that. If you magically have 2 answers and then, like, you've got 2 solutions here, then magically in your therefore statement only one of them is good, I'd be like, what happened to the other one, right? I do know what happened to the other one, but you've got to say something about it. That's just part of communication. So in grade 10, when we first do this, then all of a sudden every question that ever has a negative answer becomes inadmissible. It's like, no, wait a minute, slow down. It's got to be a reason why it's inadmissible. Applications only, right? Regular questions, negative answers are fine. And it's not even all applications. Sometimes an application and a negative value is fine, right? For time, probably not. But for other things, it could be a perfectly fine answer. So think about it always, always, always. And sometimes positive answers are inadmissible. That happens too. Okay, so therefore, the rock hit the ground in 2.54 seconds. Pretty good. Pretty straightforward. Little review from grade 10. So this next one is kind of a grade 11 question, but barely. For what time is the rock above 8 meters? Right, so that's like h, the height is 8. But what's interesting and what's kind of grade 12-ish about this is what I'm actually going to do is get when is negative 5t squared plus 8t plus 12, when is that greater than 8, right? So it becomes an inequality. Now we don't solve it in any different way. And in fact, sometimes it's awkward to do this as an inequality. So if you solved this as an equation and then just answered it that way, that would be totally appropriate. Like, this is a question you would have been asked in grade 11 for sure. So that's very appropriate. It's fine for you to do that. But technically speaking, this is an inequality. When is it greater than 8, right? So we'll solve it that way. So I guess what I'm actually going to do is bring everything over to the right, because that'll turn the 5t squared positive. So I'm going to get 0 greater than 5t squared plus 8t minus 4. Sorry, minus 8t. Let's see if that's factorable. It is. I got 144. This is going to be 2 and 2, yep. So negative 10t plus 2t is negative 8t. This is why it, like if you did it as an equation, again, you would just kind of solve it, and you would find, therefore, when t equals 2 and when t equals negative 2 over 5, right? You'd solve the question to find the two endpoints, and you'd sort of then just interpret that and write an answer. Since it's an inequality, I would have to do this. So this is positive 2, and this is negative 2 over 5. So if this is negative 10, that's a really big, this part is really big negative. Negative 50 plus 2 is negative. And this is negative. So that's going to be positive. At 0, I get a positive and a negative, so it's negative. Whoops. And then if it's really if it's a big positive number, everything's going to end up being positive, so the whole thing is positive. And this is asking, when is this less than 0, which is actually kind of curious because that's opposite from the question that we were asked, but when is it less than 0? And that is in here, right? So what's our answer here? I'm going to graph this and just let's think about this. So there's H, there's T. What does my graph look like? That was terrible, but anyway, you get the picture. One of my points is here, this is 2, and one of my points is here, this is negative 2 over 5, negative 0.4. So what's my answer here?
That's above 8 between negative 5 or negative 2 over 5 and 2.
Close. Not quite. Yeah, but still not quite. What's our answer here? Hunter, you look like you might have an idea. No? You want to say something, but you're not. Alex? Right. So what's the answer? Yeah, 0 and 2. So it starts above 8. And so like 8 would be somewhere like there, right? It starts above 8, but it doesn't exist before 0. So then we would say, therefore, my actual answer, like this is the answer to the math part. But it's not just the math part anymore, it's the real world part. You got to interpret. Okay. So therefore, the rock is above 8 meters from 0 to 2 seconds, right? Is that what we found? Take a look at this little demonstration here. So there's our graph. Okay, that's our actual function. So you can see that that's where 8 is. Okay, you can see whereabout it. Whoops, get out of there. Whereabouts it hits the ground. We found those before. Okay. Now here's the actual graph. Like there's the part that really exists, the green part, and the dotted blue part exists in math, but not in real life. Okay. Now if I turn on the 8, when is it above 8? I can shade that in, and there it is. So in other words, it starts above 8. So that just starts at 0. But if I increase, like what if it said, when is it above 13 meters or 14 meters? Well, then there you go. You'd have to shade, it would only be from here to here. It'd be between those 2 points, right? From there, well, not there, there. In there somewhere. Those points missed, I don't know why. But see what I'm saying? So you really got to think about every question. Because we didn't know where it started, or maybe it was in there, but we didn't really think about it or talk about it. Yeah, at 12, it starts at 12, but any questions? Feel okay about that? Pretty simple applications, I think, for the most part in this case, but a little bit of a grade 12 twist on the thinking. Okay, very quickly, we're going to do a factor table strategy. So if you can do it the way we did it yesterday, I would say this becomes kind of irrelevant because this is like a lot more writing, but it makes your work a bit more careful, I suppose. So if you wanted to be very careful, this would be a good way to go. If you're awesome at just doing it like on a number line, then I think that's a lot less writing. It's a lot easier. Okay, so here's what we're going to do. We're going to take our factors and we're going to write them out. And I think putting them in order is probably a good idea. So I'll start from the left, which is x plus 5. And then x plus 1. And then x minus 3 all squared. And I think you should probably put that. And then x minus 6. And then I'm going to write out my intervals. And the intervals are just like on the number line, but on the number line we just broke it up visually. So what would all my intervals be in this case? Well, x less than negative 5. Right? X between negative 5 and negative 1. Between negative 1 and 3. And x, another one. Between 3 and 6. And then x greater than 6. A lot more writing. Oh, geez. I didn't mean to do that. And this is then at the bottom is going to be like our total. So you could work across or you could work down. That would be up to you. If x is less than 5, negative 5, so I'm going to pick a big negative number again. So negative 10. Then negative 10 plus 5 is negative. If the value is between negative 5 and negative 1, so like negative 2 or negative 3 or negative 4, x plus 5 will be positive. And all the rest of them will be positive if you think about it. So if I pick 0, it's positive, positive, and positive. So x plus 1, if I pick something smaller than negative 5, that's going to be negative. If I pick something in this interval, so like negative 2 plus 1 is still negative. And then in here, 0, this is going to be positive and positive and positive. You can only keep, once you hit positive, every other one's positive only if you've done it in the right order. If you have your intervals or anything out of order, which again, I would try to do these in order and those in order, for sure, for sure, for sure. If you do it that way, then you can kind of cheat a bit. What happens here, this one's interesting. So if I pick negative 10, I get negative 13 in here. But squared is positive. No matter what, yeah?
Is there supposed to be a L type thing in the second column?
Oh, right here? Yeah. Is that what you mean?
Yeah.
Yes, of course. Okay, and this one's going to be positive, 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 positive. Because no matter what, I'm going to square it and it's going to become positive. And then in this one, if everything is negative, if it's a big negative number, this is negative. If it's between negative 5 and negative 1, negative, negative, negative. And then x greater than 6. That's going to be positive. So 7 minus 6 is still positive. So there's certainly a pattern happening there. The squared factor messed it up, but otherwise there's certainly a pattern there. And now it's just like, again, it is just like the other way that we do it, but you've got it all written out. So the total here, that's going to be negative because it's 3 negatives makes a negative, 2 negatives makes a positive, 1 negative makes a negative, 1 negative makes a negative, and all positives makes a positive. So I know in each one of my intervals, if it's negative or positive, I look back at this. When is it greater than 0? So here and here. And I answer it that way. And I would include my answer like greater than or equal to. You got to think that through. Does that make sense? See how this is like, again, this is another strategy that you would see pop up in other branches or other areas of mathematics. It's really the same idea as the number line, just we're writing out more of the work, so it's a little, you can see how it's a little bit safer, I suppose. Any questions? This is a factor table strategy. On a test, you could be asked to answer with a factor table strategy. Like that could be part of it. So it's something you're required to know. Do it once, maybe. Question number 4, I think maybe had that or something like that from the practice. Try it once. It's probably good enough. Just remember what goes across the top, what goes across the side, and then everything else kind of falls into place. Questions? Everybody good?